Today I'm going to show how to use the scaling capability of ACK. After this course, you will understand why scaling is required and how to build a scalable architecture. This course also describes the capabilities that ACK provides to help build a scalable architecture. As cloud computing develops, a large number of enterprises migrate their business to the cloud by using the cloud-native technology. This includes not only internet enterprises but also traditional enterprises that want to transform their IT architectures. Since the outbreak of COVID-19, enterprises pay more attention to cost reduction. An increasing number of enterprises want to reduce their costs on resources while maximizing the utilization of clusters and other resources. To achieve this goal, 3 steps must be completed. First, the enterprises need to allocate a budget for resources. Then they can use the virtualization technology to check whether the budget plan is appropriate. If the budget plan is inappropriate, they must find solutions to optimize the budget plan. Among the solutions available, scaling is the most ideal solution. In the pandemic era, scaling is the optimal option to reduce IT costs and maximize the advantage of IT resources. Now, how can we implement scaling in IT architectures? For example, how can we implement scaling for a 3-layer IT architecture whose top layer is the application layer? Well, we can implement scaling in terms of 2 dimensions. One dimension is generic, whereas the other dimension is much more industry-oriented. The goal of the generic dimension is to provide generic scaling capability. This means that the difference between scenarios is not taken into consideration when you apply the generic scaling capability. For example, you can upgrade the specifications of a single cluster or increase the number of containers. Industry-oriented scaling considers the difference between scenarios. For example, serverless Spark can be used to implement serverless scaling only in big data scenarios. The second layer of a 3-layer IT architecture is the platform layer. This layer is also known as the K8s layer. What factors do we need to consider at this layer? The first factor is the stability of system components. The size of a K8s cluster may change dynamically based on business scenarios. This poses a big challenge to the stability of system components. To address this issue, you can dynamically scale the replicas of some system components based on the cluster size. This ensures the high availability of the platform layer. Another factor is the stability of resource delivery at the platform layer. Resources can be delivered in the following modes: node and nodeless. The bottom layer of the 3-layer IT architecture is the cloud-native infrastructure layer. In K8 clusters, issues are abstracted into K8s objects. However, specific issues, such as issues related to storage, middleware, and database scaling, are hard to be abstracted into K8s objects. The solution is to implement scaling at the cloud-native infrastructure layer. The figure shows what happens when you incorporate the logic of building a scalable architecture into elastic components in ACK. This is what the figure reveals. Generic and industry-oriented models exist at the application layer. The main component of generic models is HPA. HPA is used for the horizontal scaling of containers. VPA is used for the vertical scaling of containers. Cron HPA is used for the scheduled scaling of containers. Cron HPA scales replicas based on the cluster size. In fields such as event-driven, industry-oriented model, CADA is provided. In refined scheduling scenarios, elastic workload is provided. In addition, Spark and Presto are improved. At the resource layer we just mentioned, resources can be scaled into 2 modes, node and nodeless. For the node mode, cluster autoscaler is applied. For the nodeless mode, virtual kubelet and VK autoscaler are applied. For K8s clusters whose version is 1.2.0 or later, ACK Pro Scheduler is provided instead of VK autoscale. At the infrastructure layer, we just mentioned storage middleware scaling and database scaling. For storage middleware scaling, CSI resizer can be used as a disk. When the storage size of the NAS disk reaches the specified threshold, CSI resizer can be used for dynamic scaling. Alibaba Cloud ACK is collaborated with PolarDB. When you implement scaling at the application layer, you can scale the read-only replicas in databases. You can also increase or decrease the bandwidth of the access layer. So, in terms of components, the elastic components of ACK provide various scaling capabilities for different dimensions, which facilitates the building of a scalable architecture.